those for the left and right systems and are completely interchangeable. The two ACMPs provide pressure to the primary and secondary flight control actuators, as well as the autopilot servos. A third pump in the center system is the ram air turbine, or RAT. The function of the RAT is to provide emergency hydraulic pressure to the flight controls in the event both engines become inoperable. Let's look at a simple flow diagram of the system. The reservoir pressurized by cools and lubricates pumps and passes through a heat before returning as a pressure from the ACM put for primary flight controls. The emergency source of power for the system. Fluid from the same reservoir supplies the RAT. The hydraulic fluid is then returned to the reservoir while passing through the heat exchanger. Components for the center system are located on the left aft body fairing. Access is provided by opening an access panel. The center system hydraulic reservoir. On the reservoir, quantity transmitter, temperature transmitter. Located to the rear of the compartment, two ACMPs. Two pump switches located on the P5 overhead panel supply electric power to the ACMPs. Forward of the pumps, a dual pressure case drain filter module, the return filter module, pressure ground connection, the return ground connection. The ram air turbine, or RAT, is located in the aft right body fairing. Located near the bottom aft area of the wheel well, a ground manual switch. This switch is used to deploy the RAT when the airplane is on the ground. Warning: before deploying the RAT, clear the deployment area of all personnel and equipment. Do not stand directly after the RAT or in its arc while deploying. When deployed into the airstream, a turbine drives a hydraulic pump to supply fluid to the center system. The pump and turbine are mounted on a strut housing which pivots on airplane structure. The RAT is automatically extended when engine RPM on both engines becomes low. The RAT may be manually deployed by activating a switch located on the P5 overhead panel. The switch is guarded to prevent accidental deployment. To retract the RAT, the turbine must be properly centered on the strut. This is accomplished by carefully aligning indicator marks on the propeller hub and swing arm. In addition to deploying the RAT, the ground manual switch will also retract it. Located next to the ground manual switch, a tachometer module. Located above and inboard, the RAT checkout module. The reservoir pressurization module is located on the keel beam forward. Access is provided through either air conditioning door. Its purpose is to pressurize the hydraulic reservoirs with pressure relieved from left and right airplane environmental control systems. The three hydraulic systems have a fin-type heat exchanger installed in the case drain lines from the EDPs and ACMs. Left and center heat exchangers are located side by side in the left main fuel tank. Access to the area is provided through this access panel. The right heat exchanger is located in the right main fuel tank and is accessed in a similar manner. Pressure transmitters for the left, center, and right systems provide electrical output signals for the quantitative pressure indication display on ICAS. The left and center transmitters are located in the left wheel well. The left transmitter, near the bottom of the mid-keel beam area, the center transmitter. The right system transmitter is located in the right wheel well. Located in the corner of the aft wall and keel beam area, the right transmitter. For maintenance troubleshooting, each hydraulic system contains an isolation valve that shuts off fluid to the tail hydraulic components. Located on the aft wall of the right wheel well, the right system isolation valve. The left and center isolation valves are located in the left wheel well. Located on the aft wall, the left system isolation valve and center system isolation valve. The control switches for these three valves are located on the P61 maintenance side panel. The switches are active when the airplane is on the ground. Let's quickly review the pumps on the three hydraulic systems. The left and right systems are powered by an engine-driven pump, or EDP, and an alternating current motor pump, or ACMP. Both pumps are normally operated full-time. The EDPs are mounted on the right side of each engine on the accessory gearbox. The ACMPs are located in corresponding left and right wheel well areas. A third hydraulic pump is associated with the left and right systems. It is called the Power Transfer Unit, or PTU. The right system provides pressure to the PTU motor, which drives a hydraulic pump. The hydraulic pump uses left system fluid to provide power for emergency operation of the landing gear, lift devices, and nose wheel steering. The PTU is located in the left wheel well area. The center hydraulic system is pressurized by two ACMPs, which normally operate full-time. The ACMPs are exactly the same as those used on the left and right systems and are interchangeable. The ACMPs are located on the left aft body fairing. A third pump, ram air turbine, or RAT, serves as an emergency source of pressure. When RPM on both engines becomes low, the RAT will automatically extend into the airstream to supply pressure to the flight controls. The RAT is located in a compartment aft of the right wheel well. This completes the program on the 757 hydraulic system. You have been shown the location and function of each of the major components in the system and have been given a description of the system operation.
This program will introduce you to the Engine Indication and Crew Alerting System, or ICAS, for the Boeing 757, powered by the Rolls-Royce RB211-535 engine. Note, due to scan rate differences, a light flicker is present on the ICAS displays used in this module. It will not be present on the airplane displays. The basic ICAS system is composed of two cathode ray tube displays, or CRTs, a display select panel, a maintenance control panel, and two computers. The left and right computers are located in the Main Equipment Center, in the E4-2 rack. Located between two computers are the upper and lower display switching modules. Each computer receives inputs from the engines and systems sensors. The computers also monitor over 400 inputs for the generation of alert, status, and maintenance messages. The upper ICAS display provides continuous primary engine indication, such as EPR, N1, and EGT. At power up, the lower display presents secondary engine for N2, N3, fuel flow, oil system parameters, and engine vibration. Below the CRTs, located on the center control stand, is the pilot's ICAS display select panel. This panel controls the functions and displays of the CRTs. The engine and status switches control the secondary engine data and status data normally displayed on the lower CRT. The event record switch is used either in flight or on the ground to store maintenance data in ICAS memory for ground maintenance use. The computer select switch in the auto position automatically selects the left ICAS computer as the primary source of information. If it fails, operation is switched to the right computer. Either computer can be selected manually. The brightness for each CRT is automatically adjusted by light sensors located on CRTs. Brightness can also be changed manually by the brightness control knobs. The inner and outer knob control brightness of the upper and lower CRTs respectively. The test reference set knob manually sets the selected engine's EPR reference bug. The maximum indicator reset switch resets the engine exceedance over limit readouts on the CRTs. Exceedance information remains in ICAS memory. Pressing the engine switch removes the display on the lower CRT. On the upper display, engine indication is continuous, shown in both moving pointer and digital form. This easy-to-read display allows immediate interpretation of minute throttle adjustments. EPR, the primary thrust indication, is shown at the top of the display. The actual EPR value is shown by moving pointer and digital readout. The maximum thrust limit is indicated by the yellow radio. Reference digital form at the top of the display and by the reference EPR bug. The EPR bug is set manually by pulling and rotating the inner thrust reference set knob, which positions the reference bug for the desired EPR. The outer knob selects right, left, or both engines. With the inner knob pushed in, the bug's automatically set by the flight management or thrust management computer. The command sector shows the momentary difference between the throttle position and the actual thrust level. As the engine thrust changes, the actual pointer moves toward the commanded level, erasing the sector. Other thrust-associated information displayed above the EPR indicators includes total air temperature, which is shown continuously, thrust mode enunciation, for which the reference thrust limits are calculated, assumed temperature indication for D-rated takeoffs, and thrust bursar status by a EV indication for in transit, and a green REV for deployed. N1 RPM is also shown in digital form and moving pointer. A yellow caution band and a red line limit are indicated on scale. If the N1 value reaches the yellow band, the pointer, digital readout, and box change from white to yellow. If N1 RPM reaches or exceeds the red line limit, the pointer, digital readout, and box change to red. When the red line limit is exceeded, the maximum attained value is displayed in white below the actual RPM. The value and duration are recorded by the ICAS computer for maintenance verification. The letters TAI appear whenever the engine thermal anti-ice system is in use. When an engine is shut down in flight, a start envelope in table form shows optimum altitudes and airspeeds to effect an in-flight start. In addition, a fuel on command bug appears on the N3, and a cross-bleed message is displayed. EGT is displayed below N1. During engine start, a red line limit appears at the starting EGT limit until the engine reaches idle RPM. Then the yellow band and red line limit identify non-normal temperature ranges where the pointer, digital readout, and box will change colors as each limit is reached. For normal flight operation, the lower CRT is blank. Secondary engine indications can be displayed by pushing the engine switch on the ICAS control display select panel. N2 RPM, N3 RPM, and fuel flow are shown in round dial format, while oil pressure, temperature, and quantity are shown on vertical scales. Engine vibration levels are shown below the oil indications. When the lower CRT is blank and an N2 or N3 overspeed is detected, the appropriate N2 or N3 indicators for both engines will automatically be displayed. Also, if an engine oil system parameter limit is exceeded, all oil indications for both engines are shown automatically. The oil pressure and temperature indicators also have yellow bands and red line limits. The pointers, boxes, and readouts change colors accordingly as the limits are reached. The oil quantity indicator has a lower white band to indicate low oil quantity without a color change. To avoid nuisance faults during the takeoff or go-around mode, the automatic display of N1, N2, and N3 yellow band exceedances are inhibited for 5 minutes from the time of the exceedance. A series of 7 Vs displayed in the lower left quadrant of the upper CRT are automatically displayed whenever engine data should appear on the lower CRT. If 7 Vs are displayed and no data appears, a problem may exist with the lower CRT or the ICAS computer. Status of various airplane systems can be shown on the lower CRT. If new status messages occur when the status page is not displayed, the status queue will appear in the upper left corner of the lower CRT. Pushing the status switch will display various system quantities, pressures, and minimum equipment list-related status messages. Also, primary control surface positions are displayed. The crew alerting portion of ICAS continuously monitors all airplane systems. If a fault occurs, a message is displayed on the upper ICAS CRT. Alerts for non-normal conditions are categorized by degree of urgency. The three categories of alerts are warnings, cautions, and advisories. A warning applies to an airplane system or operational condition that requires prompt corrective action. A warning is color-coded red. The crew is alerted visually to a warning by a red ICAS message, master warning lights, discrete annunciator warning lights, and for fires, specific system indications. All warning alerts include a bell for fires and a siren for all other warnings except the ground proximity warning system. The second alert category, cautions, are conditions which require timely corrective action. Cautions are color-coded yellow. The visual alert for caution conditions are yellow ICAS messages, amber master caution lights, discrete caution lights, or specific system indications. The RL associated with any caution condition, except ground warning system mode, is a beeper. The third alert category, advisories, are conditions which require time-available corrective action. Advisories are also color-coded yellow. The visual alert for advisories are yellow ICAS messages. They are indented one space so as not to be confused with cautions. There are no oral alerts for advisories. Advisory conditions also have specific system indicators, although some are just shown on the ICAS display. The ICAS message format can display up to 11 messages at a time on one display page, arranged by priority and order of occurrence. Warnings are red and appear at the top of the display. They cannot be canceled and are removed from view by correction of the warning condition. The most recent message appears at the top. Cautions are yellow and appear below any warnings on the display. Advisories are also yellow, but are indented one space and appear below the last caution on the display. If more than 11 messages are generated, the lowest priority messages are moved to the next display page. The pages are numbered when the system reaches an overflow condition. Pushing the Cancel button displays any additional pages. It also removes all caution and advisory messages. Pushing the Recall button causes any canceled cautions or advisories to be displayed again by priority and order of occurrence. The word Recall appears momentarily when the switch is pushed. If either ICAS CRT fails, all engine data can be displayed in compacted form on the operable unit. In this example, we'll simulate that the lower display unit has failed. Notice that the additional engine indications now appear on the upper unit. If both CRTs or both ICAS computers fail, the standby engine indicators automatically provide either N1, EGT, and N3 information. This concludes the module on the ICAS system for the 757, powered by the Rolls-Royce engine. It has covered the upper CRT engine display, the lower CRT engine display, failure displays, warnings, cautions, advisory messages, and the location of major components within the ICAS system. This program will introduce you to the 757 EFIS, the Electronic Flight Instrument System. EFIS has been designed to simplify cross-check requirements during all phases of flight by consolidating reference items on single-source instrument displays. EFIS includes the Electronic Attitude Director Indicator, EADI, the Electronic Horizontal Situation Indicator, EHSI, the symbol generators to drive the indicators, and the associated control panels for these instruments. The EADI and EHSI use cathode ray tubes, or CRTs, to display information in 7 colors. They are more reliable than their electromechanical counterparts, more versatile, with selectable information and modes not previously available to the flight crew. The information displayed on the EADI and EHSI is provided by 3 symbol generators. These generators are used to process sensor navigation and guidance data. Source selector switches are located on the captain's P1 panel and first officer's P3 panel. The switches select which symbol generator drives the EADI and EHSI displays. The left symbol generator normally provides control signals to the EADI and EHSI display units for the captain. The right symbol generator normally provides control signals for the first officer's display units. A center symbol generator is provided as an alternate or backup unit for the left and right symbol generators. It is physically and electronically identical to the left and right units. Pushing the EFI switch to the alternate position selects the center symbol generator to provide display signals to the captain's or first officer's display units. Other switches on the instrument source select panel may also select the source of data into the symbol generator. If both the captain and first officer select the same symbol generator, a level B caution message appears on the upper ICAST display and an associated oral tone sounds. This message indicates that the first officer's EADI and EHSI are now controlled by the captain's controls. The symbol generators are mounted on the E2 rack in the main equipment center. A test switch, located on the front of each symbol generator, provides a test pattern for checking on the EADI and EHSI to check system performance. Next to the test switch, a reset switch is used to reset the byte fault memory. Information from the symbol generators is managed by separate control panels on the forward control pedestal for each pilot's instruments. The upper panel controls the EADI, while the lower panel controls the EHSI. EADI and EHSI display brightness is adjusted manually using the brightness controls. After the brightness is set to the desired level, 2 remote light sensors located on the P7 glare shield panel and local light sensors mounted on the EADI and EHSI maintain the selected intensity throughout varying light conditions, including direct sunlight. Power for each EFIS component is controlled by individual circuit breakers on the P11 overhead panel. Now, let's take a closer look at the CRT displays, starting with the EADI. A conventional ADI displaying primary attitude is now presented in this electronic format. Command bars display flight director computed roll and pitch commands. Taking advantage of the CRT's capabilities, flight-related information is conveniently and selectively shown on the EADI periphery. Ground speed is presented for all ground and flight operations. Airspeed deviation is shown, normally referenced to the command airspeed bug. Auto throttle and autopilot flight director status, modes, and speed limits are shown in the lower corner annunciations. Important auto throttle and autopilot flight director mode changes are emphasized for 10 seconds by a green box appearing around the changed mode. Localizer and glide slope deviation scales may be selectively displayed by the pilot. After localizer capture, the localizer deviation scale automatically changes to an expanded presentation 4 times as sensitive as the standard deviation presentation. Glide slope deviation is shown on the right side scale. Decision height and radio altitude are displayed in the upper right corner. The decision height is selected on the control panel, which also sets the corresponding EADI display value. When the airplane passes through the decision height, The number becomes a flashing DH, and both decision height and radio altitude indications change to amber. Now, let's look at the EHSI. The conventional HSI that you have used in the past shows the relationship between the airplane and an en route or approach course. The EHSI in the new airplane can present this same information electronically in several different modes. In the full ILS mode, heading, localizer, and glide slope are provided in a familiar format, and tuned ILS frequency is displayed here. For all modes, a digital readout in the box above the compass pointer displays the compass pointer value in either magnetic heading, shown here, or magnetic track, which will be discussed later. Also, for most modes, relative wind direction and velocity are displayed. Let's take a closer look at the EHSI display versatility. As mentioned earlier, the EHSI can be operated in various modes as depicted on the mode selector. We've seen the full ILS mode. Now, let's examine the full VOR mode. This display is similar to the previous mode, but has conventional VOR course deviation and to-from indications. By looking at the essential information in the top half of this full VOR display, the expanded VOR mode improves this presentation with a new uncluttered display. The airplane symbol, now a triangle, is at the bottom of the display. The compass rose is now shown across the top as an expanded 70-degree compass arc. A dotted line extends from the airplane symbol to the selected heading marker. The marker is controlled by the heading selector on the glare shield mode control panel. A conventional course deviation indicator is used. A line projects from the course pointer to the desired course on the compass arc. A track line extends from the airplane symbol to the compass arc to aid in course tracking. In the expanded ILS mode, the display is almost identical to the VOR mode, but shows localizer course deviation. As in the full ILS mode, it also adds glide slope information on the lower right scale and tuned ILS frequency. The map mode aids the crew in maintaining a mental image of their flight path by presenting route information against a moving map background. The orientation is now track up along the current track of the airplane. The track line becomes a cursor, projecting from the airplane symbol directly to the box, which now displays magnetic track. Drift is shown as the difference between the magnetic track and the heading pointer, which shows the actual airplane heading. The number at the midpoint of the track line represents 1/2 the map display distance coverage as selected by the range selector on the EHSI control panel. The range can be varied from 10 to 320 miles. The flight plan defined waypoints are shown as stars. A solid line representing the flight plan route connects each waypoint. When a waypoint becomes the next one being flown to on the flight plan, its color changes. Flying the track line cursor over the flight plan route simplifies the course tracking task for the pilot. During turns, a trend vector displays projected flight path based on bank angle and ground speed. Up to 3 segments may be shown depending on map range, with 30, 60, and 90-second positions indicated. Distance in nautical miles and ETA to the waypoint currently being flown to on the flight plan are also shown. The final EHSI mode is plan. It shares some features with the map mode. Visualize a line across the top third of the CRT. Information above the line is identical to the map mode display. The data below this line are map and flight plan information oriented north up for flight planning purposes. The information display is similar to that presented on navigation charts. This arrangement allows the crew to monitor flight conditions while planning. The plan mode may be used when reviewing a flight plan to step through and examine each leg. Now, let's look at the other controls associated with the EHSI. Pushing the weather radar switch displays weather radar returns in 3 colors. In the map mode, as the range selector varies the range and scale for the display, the weather returns change accordingly. The flight crew can now directly relate their route to any significant weather ahead. This feature is only available in the map, expanded VOR, and expanded ILS modes. The map switches allow selectable information to be displayed on the EHSI in the map mode. For example, pushing the Nav Aid switch brings up additional navigation stations on the selected map segment. Pushing the map switches a second time removes the added information. When the route data switch is pushed, mandatory crossing altitudes and ETAs for the flight plan route waypoints appear adjacent to these waypoints. The map switches may be selected individually or in combination. This enables the crew to control EHSI display information and clutter. To summarize, this program has been an introduction to the Electronic Flight Instrument System, or EFIS, which consists of the EADI and EHSI cathode ray tube displays and their controls. The EADI displays primary attitude and flight director steering bars in a conventional format, while flight-related information is conveniently and selectively shown on the instrument periphery. The EHSI can present pilot-selectable information in conventional VOR or ILS formats, expanded and simplified VOR or ILS displays, and unique map and plan modes. Selectivity of the CRT information is accomplished through control panels provided for each pilot. This completes this program. You have seen the location and function of each of the major components in the system and have been given a basic description of the system operation.